Okay, good morning, everyone. This is a Medici 2 tutorial. All right, so goals, provide some context for why a rewrite for version 2. This tutorial is going to focus on version 2. Get everyone comfortable with the version 2 code base so that everyone can contribute by the end of the tutorial. It's mostly hands-on. Not goals are discuss version 2 in depth or version 2 in depth. Really, this is not a let me tell you about all the things that you've done over here, all the features. It's more, let me give you kind of a broad overview of what we're trying to do with this particular project, why we do the rewrite, what's in the rewrite, and then hands-on. This is the agenda. Um, I'll do a short, maybe past, present, and future. Then I'll do a code review of version 2. Ideally, by that point, you have your code with the code checked out, so you can follow along inside the code. Then we'll together write an extract or write a preview, okay? And learn what those are. My goal is to stay within 45 minutes for each. Somebody help me out. Happen, of course. Okay, so before I get into the past, present, and future, this is the list that was sent out yesterday. I apologize for the kind of short notice, but these are kind of the software you need to get kind of the full system on your machine running and follow along during the tutorial. If you don't have this all installed, I ask you to look at it. We'll have time after the first 45 minutes to go over it. Somebody has issues. Some of us have some know, but if you want to follow the tutorial along, you gotta have all of this. Okay, so brief Medici past, present, and future. So when we started with this project, this is how we talked about it. We said we want to manage large collections of multimedia research artifacts. So the emphasis was research, right? Research data. And we wanted to, we wanted to do large collections. Okay? So the goal here was build something that would scale. We started by focusing on image data, and that was mostly because we had use cases that had a lot of image data. But soon we realized that we really didn't have all the focus on image data. That the system that we were building, the library that we were using, just allowed us to use any kind of data. And so we switched to making a system for any type of data. And this was also facilitated because under the hood, the main library that we were using for storing information called Tupelo, which was developed here at the USA. And what Tupelo did was it managed RDF triples for all kinds of information around the original blob, binary blob. And then it helped also store the rigid blob. So right from the bat, the libraries that we were building upon had this idea of you have a blob of bytes, and then you have arbitrary metadata about that byte. And Medici was a way to kind of create a end user application. So a service that you can access and specifically have this discussion around collection of data sets. When we started, we're splitting the development between both a web and a desktop client. So at the beginning, we had both. Right? We had the web application that you can connect to. We also have the front and both are off the same back then. So what happened is that over time, we realized that so what happened is that over time we realized that certain things were very successful about the project and resonated best with the audience. First and foremost, people started looking at it as decentralized cloud storage. So this idea that every community or every lab could install their own instance and use it as cloud storage. Now this, this is 2009, Dropbox becoming pretty popular, but and still, right, when we were starting, itself was the idea that, well, that's a centralized place in the company. If you're doing research, you want to have full control of the data, or maybe you have a lot of data, and so you don't want to send it to the internet. Like, the first thing that started resonating. The other thing was this idea of flexible metadata support. We were using Tuple and RDF for that, but really the big idea was that people liked the fact that you didn't have to have predefined ontology, and that you could, the system, allowed you to put in whatever metadata you want around the specific file. So it was also kind of useful for people to use this as a way of specializing a generic system for storing information for specific use. And the thing that we sold over and over and over was this idea of you can add to the system extractors and previews, where extractors are once you upload something, the user doesn't really do anything, they just upload. They don't necessarily decide to run on data. But the system itself tries to run a bunch of extractors to extract information from the file. And these extractors, the idea was you can write your own specific to your use case in your community. If you have microscopy data, you multiply, and you're trying to find algorithm, computer vision algorithm, or finding tumors, right? You can create an extractor that does that. So every time somebody uploads something, you run together. Right? So make it very thin, and then in the background, sometimes. Also, previewers. This is something that was very successful. The first one that we made successful was something based on the Microsoft tool kind of pyramid technology. Feedback. The idea that the extractor create a pyramid out of a very large image, and then you can zoom in and out in the browser without having to download. So these were successful, right? Over the years, people seem to like this, they find it useful. Also, text-based search and push annotation were pushing hard, and people like the idea of discovery, but text-based search, which you're familiar with. Social annotation, the idea that you can more freely organize information using tags, and then allow the user to kind of go in and find related. We also did something called relationship assessment. I want to create a file type. So again, these are things that were successful at the time, that have been successful in the project, and things that we don't want to lose their core kind of features of the system. So here's a timeline in terms of development. We started development in November 2009. We did the first public release less than a year later in June 2010. We added features in 1.1 that November, and then more features in February 2012. In 1.1 and 1.2. So at this point, last summer, we decided to kind of sit down and do a review. 2 years. So I'll tell you a little bit more about it in a second. But we decided to start, the development of this version 2, which is a complete rewrite in November 2012, last year. In the meantime, the seed project continued building on the 1 release, and there are new features in it that hopefully plan on the 1.3 based on and really what we would like to do is to have a usable version like end of this year. We already have a bunch of features in it. It's not stable enough. Yeah. So, the review of summer 2012. It was a hot summer in the prairie. No, but really, it was kind of an interesting summer. That year, we started realizing that we hit a ceiling with the number of architecture. Everything inside the system was right, of information, and we were storing them in MySQL, and because of the way we were storing them, there was every time you query, so that obviously kind of tough on us to try to scale the system. Um, we're using Tuple, like I mentioned, and Tuple became really difficult also because the main developer had left. So we had a large piece of code base. It was just really hard for us to maintain. We had something that we didn't think about at the beginning that was kind of annoying. Everything that version 1 of the application, and I can show it to you briefly, but it was built using full web tools, the compiler for Java. So it was a rich client application, which means that everything on the UI is created by the JavaScript, right? Which means that by default, the search engine goes, it gets the JavaScript, but it doesn't really have the content of the page. Now, one of the things that we did in Medici is we allowed people to make this public, so that people could discover them out there online. But because it was JavaScript, the search engine has a really hard time finding it, so we kind of were stuck, right? So that was kind of one of the things that we kept going back and forth. And also the other thing is we worked with GWT since the beginning for many years, but every time we tried to take JavaScript libraries outside of GWT and try to make them work together, it was very cumbersome. Like it would take days. We still didn't know how to get it properly. Sometimes it was trivial, right? Other times it's almost impossible. And the thing is, as you know, over the past 10 years, there's been all sorts of JavaScript libraries developed that you want to be able to use. And so every time it was a nightmare, and that was a big problem. We also were storing a lot of state inside the server, right? So the app was a Tomcat-based, servlet Java-based server-side application. And as you know, if you develop this kind of application, you have a session where you can store about information, right? So if a user logs in, you can store information about the user, right? So you can keep that state in there. We started storing all this information in the session, and the problem is that does not help you scale horizontally. So if you want to put a proxy in front of it, and you're coming in with different requests, it makes it very difficult to make sure that you're hitting the right server, right? So it was also, this made it difficult to take the web app, put it on different machines, right, and scale the web app itself. There are ways to do that, but so for example, Tomcat comes with a kind of shared memory session, and we could have taken the session out and kind of abstracted it in a different service. But it was one of those things where, going back to scalability, and just the way it was architected, it was very difficult to do that kind of thing. So we decided to go back to the drawing board and figure out, okay, what can we do better? If we were to, should we just try to fix what's broken, or improve what's broken, or should we start from scratch? And we highlighted the usual kind of priorities, which are usual, but in our case they were very meaningful. One was scalable, because from the beginning we said we want something that's scalable. Maintainable, because some of the problems that I mentioned with GWT and where that it was really hard to maintain. Right? Every time we had to change something, it was hard. And extensible. From the beginning, that was one of the things that we solved. Right? That was really, really helpful. It was this idea that you could write your own extractors and your own features. But doing that itself was very, very costly. And I'm not going to focus on it, but if you're curious, right, so we can tell you about what it took, in version 1. And it was very difficult. You had to recompile literally the extractor or the web app to add new extractors and new reviewers. So it was very heavy, it was very costly. So We also wanted to improve the design. There were things that were missing. We're talking about wanting to add more the idea of projects, or you can call them groups or spaces, to moderate access and provide the ability of having groups. We were selling Medici as a way of you would install your own instance of Medici, and that would be open to your group. But if you had two different groups that had to keep the data separate in one space and then maybe share specific data sets, we couldn't do that. So that was just a feature that was missing, and we never built. We wanted that, because it kept coming up. I think this thing, this idea that once you have a lot of information going through the system, it was very, very difficult to know what was happening. So you could go there, right? You can go there, you can see it, and see what the latest data sets that have been uploaded are. But if you have a lot of data coming in, you really have no simple way of finding what's going on, and that's just not, not helpful. We wanted to improve the retrieval. We were doing primarily text. We wanted to do a couple of things. One, signals. We wanted to be able to tailor kind of the searches based on activity of the users and all that. I also wanted to start doing multimedia, because again, the emphasis here was different data types, any data type, and a lot of data that we deal with is image, video, right, audio. So, and we were doing work in multimedia context retrieval. So we said, okay, this would be ideal. And maybe enable demand processing. So this idea that the extractors, right now, they just run behind the scenes, right? So you register extractors, they run. But we don't have support for tools that a user can just execute on a data set. We had that somewhat in the desktop client of Medici version 1, but it wasn't the easiest kind of setup to distribute that like this. So, again, I apologize if I'm just talking more minutes. All right, so this was the architecture of version 1. What I want to emphasize here is just a few things. One is, so everything in blue was kind of custom code, external resources. Everything in lighter was just gray, was code, Medici code. So we had a Medici web application, Medici WP code. We had a Medici desktop client built in Java and equipped our. We had a Medici web server provided by these interfaces that had full abstraction. And then everything was stored on disk in an RDF store, which in our case, that should say MySQL, because really that's the one that all the blobs would go on the file system, so it would literally get directory disk. Pre-processing extractors run together. That's kind of leading, but they all run together in one process as a service, and web app called to. So so that particular service is keep compute inside, right? But there was really one service. There weren't many. So and the Lucene index to the text search was on the same machine as the web server, because Lucene is a Java library that by default writes to this. So what happened was that, if you look at this picture, everything that is on the server side kind of had to live on the same machine. The only thing was the RDF store that was somewhere else. We could take the file system and kind of mount it remotely, but it was primarily kind of a one-to-one kind of, right? One pair. Machine had to be on the same machine, and the pre-processing extractor could be on a different machine, but it had to be on one different machine. So we never really figured out how to well kind of, right? We did have that desktop client, which allowed you to run some external tools on it, but that was problematic. And after a while, we stopped supporting the desktop client just because. So this was what was in version 1 technology-wise. I've mentioned most of them. Most of you are probably familiar with all these technologies. Yeah, so and this is what is in version 1. So you have that Google Web Toolkit, Java to JavaScript, all the UI was done on inside the browser. On the server side, it was plain Java servlet. We had some plain JavaScript, Flash applet, Java applet, kind of previewers. Apache stream might be stored script. Extraction service, it was an Eclipse RCP app. I mean, it is an Eclipse RCP app with Java. I don't know if you guys are familiar with it. Rob mentioned, right? You're familiar with Eclipse, right? And he mentioned the plugin mechanism, right? How you can install plugins. That's the mechanism that the service and the client. And inside the desktop client was the cyber integrated workflow management system that would handle actual. But those are the people that, right? So run as local on the cloud. So this is kind of okay. So this is what it looks now. So we dropped the desktop application because we had the most success with the web browser. There's a lot you can do with the web browser nowadays, and there's this idea of sharing on the cloud, sharing with other people. It's not that we can't have a desktop client, it's that at this point we're focused on the web browser, and also custom code. In the previous version, we had a service. You can see that HTTP, REST, Sparkle, Zika. Those were the protocols that we issued the server on. That REST part was actually very found REST that. And in fact, what we do nowadays is we do a lot of very Sparkle. Sparkle is a query language part. So this does not go into detail about what's inside the web app because we're going to go and look over the code and learn everything about it in a little bit. But there's a couple of things that we can do. One, we start by saying, okay, we need to be able to, put this load balancer in front of many web apps. So all the web apps, individual web apps here, can run on separate, right? That's the goal, and that's what we start testing. And so that means that no session can be stored inside the web app, right? And before, but that's fine because there are other ways to do that. I'm going to tell you about the technology a little bit more in detail in a second, but the web app is written in Scala and Play. I'll tell you more about it in a second. Then we have this cloud of services, and all of these, again, are kind of standalone that can run on many machines, right? So we replaced Scene with that Elasticsearch service over there. Again, while Scene, you write this, write collaborative, write so you into this. Elasticsearch builds a service around that, so you can talk with the network. You replace the data metadata store with both the blog and the metadata around the blog. Right now with something we introduced Versus media search. I put a cloud of external services there to basically say that we're trying to make the web app work and many others in a simple manner. So then that event bus is this one big addition. If you remember, before I mentioned that the service was an Eclipse RCP, one process running one machine. So to scale, what we did was introduce an event bus where it's published and subscribed. So you send a message on it, and then there's a bunch of subscribers below it that can listen to the message and pick up the one. Again, so that means that those extractors are standalone processes running. So really, in this picture, every single piece here can run on a service separately. And on top of that, many of these are built to run on many machines themselves, scale. So ideally, every piece of the puzzle, right, you can run on many machines, right? Resources add, right? That's the goal that we're trying to achieve. So I have a few slides on some of the technologies. I'm not going to say too much because during the code review, I can kind of tell you more and while we look at the pieces and all them in front of themselves talk about some details. I just wrote down some of the kind of key things to take away. Scala, which we use for the web app, right? That's the web application written. It's a language built on the JVM. So it runs on the JVM. It's like Java, like compile, right? So that means that you can use Java live you can just literally put a jar on a path and call it from inside Scala. Okay. So the reason why this is really important for us is that we have a lot of Java experience and a lot of Java. So there is a lot of other systems and all our languages looked at, but they're not Java, and okay, we didn't that's good for us. Also, the JVM is very, very, very performant. The virtual machine out there compared to other languages, right? It's really fast. And so like still like virtual machine, kind of that. It's also kind of an interesting piece because it really mixes object-oriented programming and functional programming. So other languages are either one or the other. One of the unique things about Scala is that so you can have hierarchies of objects, and you can have first order functions and pass in other functions and all sorts of function programming with it. Some people find this very confusing because one, it's a mix of many things. It's not you usually see that, and also I find that a lot of people don't have a strong functional programming background. I do it either. But once you get used to it, you can see that there are that. So that's very unique to the language. There's an actor model for concurrency. So instead of handling threads like we would in Java and actually manually handling threads and decide, what on the thread, they have this abstraction, which is the actor model. You can look it up. It's a pretty interesting model. Has been around for a while. There's all sort of research done on it. And it's a model for concurrency. I'm not going to say too much about, but besides saying that the way it works is instead of worrying about threads, you have actors and they have mailboxes, and then the system under the hood takes care of synchronizing really the data they send mailbox actors. So what you can do is that the system and how to run actors and when. So they're kind of like lightweight threads, right? Where you have threads under the hood, but you don't have to worry about that. Usually, also that's very, very difficult to make that long. So it's just you can read about it. We can talk more about it afterwards. But it actually allows you to write code that's highly concurrent, a lot easier than you would Java. So you can really have of to their fame, I put this in because people, like to talk about Scala. Some of the comments that you hear is that it's difficult to learn. It's very academic because it's done by someone, by a professor in Switzerland, and it is somewhat academic. There is also the things that are very difficult to grasp in it. But that being said, Twitter rewrote the entire backend in Scala after Ruby Rails failing them, and now it runs in Scala. So you have a very practical application that you can Scala. So that's just an example of, okay, yeah, it's academic, but it's not like you can't. Play is you'll get to know Play very well today. There is actually a Scala and a Java version, so you can actually write Play application in Java. It's based Scala. We're using the Scala version for provided in the previous slide. One of the things that when we're looking at Play, so right, Play compares Rails for Ruby or Django for Python, right, or Express for Node.js. But the cool thing about Play that I really like is that, and a lot of people like, is that it's lightweight and modular. So and Ruby on Rails is becoming like that, Django more or less. But the idea is that at a minimum, Play just is a simple way to route requests to the controller, and that's it. Like at a minimum, you really don't. There is not a lot of machinery that you have, which means that flexibility and you can't get stuck like could, the other frameworks that provide a lot of advanced functionality, but you have to work within the limits of the framework. It also builds on two technologies that are very important. One is Akka.io. Now Akka is part of the language. When it started, it wasn't part of Scala. So you'll find Akka actors. They're a type of actors. So what they did was they took the actors in Scala and they improved them. Now it's part. Now that they've been contributed back. But they're just an advanced version of the Scala actors. And the cool thing about Akka, which I hope is more in the future, I'm trying is that it's high performance concurrent like the basic actors, but it also gives you remoting ability. So you can write code that can run in one JVM or one machine, and the same code can run on multiple JVMs in the cluster. So that's kind of an interesting, feature. And one of the experiments I'm doing right now is I'm trying to use that to write a better distributed system first talk about it. But anyway, so Akka is part of Flame. The other one is Medici.io, which is event-driven network application framework. Again, you can look it up, but it basically, in a way, replaces the servlet framework, if you're familiar with servlet. And while a servlet is, every request is a thread, Medici.io has an event, and that allows you to scale, much better because you're not going for every request, creating a thread, you're going fast. That's why it's asynchronous, kind of like Java. RabbitMQ, publish, subscribe. Again, this is a proven, two things. One, this is a proven model for kind of scaling on a cluster. It's done in many different contexts, very similar. You just have queues that you publish on them, and then, you have all these properties that take off, right? Queuing mechanism, right? It's done everywhere. We looked around and we picked RabbitMQ for various reasons. Really, the main reason I would say is that it's very solid. It's written in Erlang, and Erlang was one of the first languages to implement in production that actor model. So the Scala actor model is based on Erlang actor model. And Erlang and RabbitMQ, but Erlang in general, I mean, it's so robust that a lot of communication companies, companies, they build a lot of their communication software in Erlang. Good idea of how. RabbitMQ has been proven of Reddit fame. Reddit uses it as kind of a buffer between requests from the web and writing to the database. The database is endless, so everything goes, right? And this is just an example. There's also another example. He uses a standard called AMQQ, which other event bus systems like ActiveMQ implement. So really, you can just learn that standard and write your drivers however you want in whatever language you want. Ideally, you never have to learn that and look at it because it's really complicated. And really, so far, we haven't had to because it deals with the derivative library. Drivers in both languages. So this is the event bus, right, that extraction log. Every time a file gets uploaded, there's a message that goes with this, and out there are, extractors. MongoDB. We started with MongoDB because for many reasons. One is, as I mentioned before, what we liked about RDF is that it's somewhat schema-like. You don't have to have a defined all. You can have one. But that's not just a property of RDF. That's also a property of what are called NoSQL database. That's one of the properties. It's an umbrella term. It's very generic, right? It's not one thing. But the idea was that we wanted something where we could add metadata or information about a file, or however we wanted the flexibility instead of having maybe the relational database. Rebuild the table, modify the table at the time. Doing that. We had experience with MongoDB on another project, consensus project, and we're pretty happy with it. It also, inside the NoSQL kind of umbrella term, MongoDB belongs to document-oriented storage, which means type, which means that the unit, the basic unit, is a document. So instead of doing kind of columns and rows, the idea is the basic unit is a document. In this particular case, it's a JSON document, or similar to which is the map of maps, if you're familiar with JavaScript, right? You have key value, where the value can be another map, right? And MongoDB supports that. One of the other things that was really nice about MongoDB is that it has this standard called readfs to store large binary files. You can actually put large files in it, and it chunks the files up, all the chunks, and manages all the chunks. And so if you do it, because MongoDB comes with sharding or replication out of the box, that means that you can deploy a bunch of MongoDB nodes on different machines, and when you write a large file to it, it will handle chunking it up and putting it on multiple machines. The sharding or replication out of the box was a big deal for us because we didn't have simple ways of doing that. If you want to do that with there is a clustering for MySQL. We don't have a lot of experience with it, but in general, a lot of that is done manually inside the actual application with relational databases. We could have done that, but we said, okay, why not pick something that has that and see how it works. Also, this one has a lot of drivers, languages. It got a lot of funding last year. It's very popular, and one of the reasons why I think it's very popular, and a few things are popular, is that it's easy, trivial to install and get started. But the funny thing is that, we've seen some of this, and some people complain that it's difficult to manage large clusters, large, a lot of them. And difficult means that, you need to know features, right? Which is not necessarily a showstopper for us, because at that point, have a system that large and learn how to write. But I'm putting it out there to, as a caveat, because we are looking at alternatives. Last piece is Elasticsearch that I'm going to briefly mention about. Like I said, we're doing text-based search on Apache Java library. Elasticsearch wraps that as a service. You talk, RESTful web service, JSON, nice, API. It's distributed out of the box, kind of like MongoDB, right? It handles doing the sharding and replication. It's kind of set up. Again, we don't want to rebuild that ourselves. It had track record, and this was out. There's a lot of projects where there is also all sort of like features in it, like and other things. They're not currently used. It's also Java code. So I'm almost done. Just a couple of slides. So these are some of the things that we're doing in version 2 that were not in version 1. We're introducing spaces. I mentioned project, what that is. This is going to be the main way of doing space access control. We have a branch that you can look at to get a better sense of that, how that's going to work. But in a nutshell, there's going to be a public space, the web, community space, which is that particular instance, a private space, our own space, and then a bunch of space in your project you can create on a type of space. All right now, the design is all access control is against the state. So somebody wants permission, wants permission to space. This is something else that we didn't have version 1. Right. Do it like all that. We're introducing file versioning. We were doing so in version 1. We would not let people edit the file, so they would create a new version of it, but then ideally they would put a link between previous next. The problem was that because the system was built that way, every time you made a search of something, you would get all the different versions of the results. And that was very disruptive because make it very hard to use. You might get, the same file, 100 versions, but that's all you need, right? So we're trying to add file versions because of that, not because we want to allow the user to necessarily edit a file and overwrite the version, but we want to kind of hide version. We want to have the ability of have multiple files in a data set. If you play with Medici version 1, you'll see that really a data set is one file with a bunch of. And there's so many instances where we wanted to have the unit data set include multiple files. And the way we're getting around that, we were saying to the user, hey, upload a zip file, right? That's one file. And then we look inside and think, which is still fine, but it's kind of awkward because now you have a zip file. It'd be nice to make it explicit and work on the file inside instead of the file and have special extractor for the zip file. Then work for media search. So find more images, videos, and audio. We're not going to really look at this very much today. We have the first step. We're implementing it. And better relationship management between data sets, again, like being able to create data sets and add. That was something that we kind of did as a student project, an undergrad, built that, and then it actually. There's also a few things that we're trying to do that are unclear at this point, but really we haven't done a lot of development on it. But we really would like to do. One is the idea of on-demand execution on the web. So it's very simple. In the web, you can say, I want to run on data set and then run server side. The reason why we want to do this is because we really kind of think that the extractors, right, anyways, there is no reason why we can't make special, right, extractors where you're actually defining I want to run it, and maybe they can pass parameters. The extractors cannot have parameters in their head. Right? They run whatever they want. When introduce linked data services, I might have noticed I haven't really talked about RDF in version 2, right? We're storing these JSON, MongoDB, right? There's no RDF in the picture. The reason is because in our design, we feel like we can do that at the service layer, where right now, when you use the API, it's like call to it to JSON. But there is no reason why you can get RDF back. And really, this is what is called linked data, which is very popular, has become very popular since we began working with RDF. So what we were doing was we were using crypto, stored crypto, and they're kind of a backhand thing. But then people started, asking, well, how do we use crypto? How do we share them? Because the big thing that they're portable, they're easy to share with other systems. And one of the answers was the idea of built service, fit purpose, so then you can use inside of it, right? And that's very much of a kind of rest of the service that's out RDF. And we have some ideas on how to map things between the internal representation. Yeah. We also begun some preliminary work building different backends. Cassandra is something like also alternative. We're going to talk about why. Start saying that they're very well played project, very mature project by now. We started where, and Cassandra in particular works really well with large clusters. So for example, metadata. And then the loop file system, because like I've mentioned, so right now the blob files are stored either in MongoDB that you access or on the file system. And having them in a file system tool because there's one of them that have. We also have some work. This is actually there's a branch with work code in it where we are using PostGIS. Some real, I say real traditional version 1, we just go lat along in one projection inside the RDF, and then now we have more than. Okay, so almost done. Wow, 45 minutes. Good. So then we start. So really, what we're asking ourselves now is, is this the same thing as we started with? And the other thing is that people keep mispronouncing the term, which is, the name Medici, which people say Medici, and it's kind of an awkward name that people, I don't know, maybe because of my background, it sounds more harsh than yours, it really is. But one thing that we're considering right now is change the name of it, kind of make it clear to people. Very, very different, right? Because before, still say that it's a continuation of version 2. Medici, make it clear, right? There. But maybe, we were looking around for names that are easier to pronounce, remember, right? Remember? And so one option right now, the one at the top of the list, is the following. Or open research content. It's easy, it's short, funny, and we have all sorts of taglines that we're coming up with. It's goofy, but yeah, that's what we have. In terms of names, if you have ideas as you get more familiar with the system, please let us know. For now, for us, still Medici version. So that's all the slides that I had for kind of an overview. At 45 minutes, we can take a quick break, and people can ask questions, maybe 10 minutes. And then the next thing is I'm going to bring up the code, and I'm going to start running everyone through the code. That's going to be another 45 minutes. And then hopefully I'm going to get everyone to the next practice. So, question. See, I had to wake up. I really did. Yeah. Yeah. Yes. Yeah. So in version 1, yeah, I'll repeat. So which extractor extracts what? What is extraction based on? Version 1, it was only on the MIME type. So based on the MIME, so we create an extractor just by a MIME type. Anything with that MIME type, and no MIME type is major and minor version, right? And we could do just major. But it was only MIME type in version 1. In version 2, we're trying to prove that what we do now is we prepend to things like type, like data set and file. Right, version 1, a data set, version 2, a data set. So the idea of extractors that work on the entire data set instead of a file. So for example, if it's a shape file, from a shape file, have all the files right? Want all of them. So we're adding that, so I'll show you what the do is like. We also, would like to add more. And I'll show you once we get started. And I'll try to install all of these. I know it's a long list, but they're actually pretty useful beyond this project. And really the only one in this list that is somewhat difficult is RabbitMQ, because you need Erlang. Depending on what platform you're on, it might be a little more involved. But MongoDB, just unzip and you're done. Virtual environment is the same, just kind of on the path. Scala IDE is one big download. And with Scala IDE, you can download it standalone, and it comes with Eclipse and everything else. So if you have Eclipse already installed, you can install it as a plugin. SVT is the same thing. You just kind of unzip it, and there is a bunch of scripts you can run. Java, probably most of you have it. So that's the part. All right. any questions on or any difficulty here? Maybe it's not me, maybe someone else here can help you, so don't be shy. If you have all of these, then great. Yeah. All right. Okay, so code review. All right. So this is the code that you have to check out. It's under open source dash. I'm going to go to the URL right now and I'll show you. If you don't have it checked out already. So under Medici, dash Medici, you can see there's a long list of extractors here. The GWT stuff has been added recently, this is version 1. Medici Play is the web application. You click on here, say clone, this is your URL, and you have two options. This is my flip for Scala ID. You can come here and you can just copy and paste the URL in this list, or you can do it from the command line. Just a good clone and that the URL. When you first check it out, the project does not have the clip project files in it. So if you try to import it directly from the clip, it's not going to recognize it. So we have to go to command line first to create the clip project. So once you have checked out the project, I'm inside Medici Play. What you want to run is simple build tool, SBT. Now, inside Medici Play, there is an spt.bat and an spt shell that you can run. SBT is just a Java library that look at the script. All what is running is just Java with that spt jar local. I'm going to use an SBT that I have installed somewhere else because that's the latest version. I mentioned 0.13. But you can try if you want the one inside the folder that you checked out. Both should work. So, what is SBT? First time you launch it, it brings up, it loads a configuration file. So it knows all the parameters for this particular project. I will show you in the code in a second what that looks like. But what you can do with SBT is you can do things like, so the first time you run it, it probably is downloading a bunch of jars, dependencies. If it doesn't, you can do an update, and it goes and double checks all the jars depend on. SBT, under the hood, uses Ivy, Apache Ivy by default. But it can also use Maven. And in fact, it can use both at the same time. I think I can show you an example. But by default, it's using Ivy for dependency management, okay? All the jars. So you come out of it and look under your, come out of it and look under IV2, your home directory. You'll have a cache, and inside the cache, just like Maven, you'll have a bunch of folders for each project and all of that. So it's centralized, okay? So the idea here is that you do not put the jars inside the project. You put dependencies in other jars, and then you resolve them and update them. And that's very important in the development process, because every time you update jars and you have to go to SPT to make sure that things are working. I'll show you how to do that in a second. But I just wanted to make it clear where all the jars go. It's very similar to game. I'm going back into SPT. Of course, there's a bunch of other targets. There's the clean, which you want to do sometimes when you're trying to update jars or other things. It removes all the compile classes, all the jars that depend on, because sometimes you'll have jars that are, for example, snapshots. And because they're snapshots and they didn't have an ID, to get the latest version, you actually have to tell it to delete what's there and get it again. So I'm going to do clean and then update. Now, this SBT is generic, it's not specific to Play, right? Simple build tool for Scala. But Play comes with a bunch of plugins for SBT. So one thing to keep in mind is that if you go to Play framework and you download what they have here, you'll get a command, you'll get a bunch of scripts. One of them is Play that you can run from the command line. Instead of running SBT, you can run Play. That is really running SBT under the hood. I don't really use the Play target. I just use SBT because you get the same target you get in Play. You can try to Play, just keep in mind that they're pretty much the same thing, really. You get the same thing either with SBT or Play. The nice thing about this is that you don't have to install the Play kind of framework, right? The other cool thing about it is that SBT actually is getting all the Scala library, right? All it requires for SBT is that itself Java. So you actually get a Scala. Okay. Okay. So now some of the targets, basic targets you can run are that you want to be aware of are run, which allows you to run the application in development mode. Okay. So there are different modes in which you run it. Run is in development. That means that if you make changes to your code, they're going to be hot reloaded. They're going to be reloaded. Play comes with something called start. That's actually production mode. So one of the big differences between start and run is that start, because it's production, it doesn't do hot reload. So if you do start, one student here, start and we're making changes, and then he wouldn't see the changes reflected in the app. That's the why. Start kind of when you're running point production, and there's a bunch of different too. But really, you want to run. Now, before we run the app, there's a couple of things that you need to have run. The major thing is Mongo. You need to have Mongo running. That's really right now the biggest requirement. So if you have Mongo running, don't let's click. So all I did was I went to Mongo and directly the one that I downloaded, and I'm just running this Mongo D. That's the daemon for Mongo. So you can all go there and run it, depending on how you install it. System package manager on Linux, possible that it's running as a service. You can see that it's running for 28.17. The other thing that's always helpful is in one window have a Mongo running. So you go again inside the bin directory, there's another target, another script called Mongo. That's your client to the server. Okay? So you should also start that. So that way you have a simple way to kind of look at what's inside the Mongo data. Okay? I'm going to assume you have both running. And go back to Mongo. You just run Mongo in the Mongo. There's also parameters you can pass in MongoD, and you can pass configuration files. this is all kind of out of the box. It assumes a bunch of defaults that are very, very useful for it. It doesn't require password, it doesn't require anything. It only listens on localhost, so nobody can access it from the outside. So that's one of the things, right? One of the reasons why it's popular. So once you start MongoDB, it should start. If it doesn't start and you have problems and you're on Mac, you might have to create a directory for the data because it's default. So no errors. Okay, so now we go back to the SPT shell and we run and starts listening by default on port 9000. The first time it might be compiling, so things will change compiling. You get compiling Scala sources and Java sources. Once it's done, you'll be able to look at the browser and say localhost 9000. And if you don't have runtime error, this is one of the annoying things about one of the few annoying one of the annoying things about Scala is that sometimes compiling takes a while. They're trying to improve that. There we go. All right. Debug, info, all sorts of information. Console. Okay. Oh, it is really not. The problem is, I'll show you what that looks like in a second. Okay. That's okay. I'll just run right over. So Elasticsearch, RabbitMQ. So let's go to the code base, and I'll show you how it's firing on and off. Okay, so, okay, sorry, so going back. Okay, so this is the app. Everybody should see this. If you're not seeing this, then ask the person to the left. Oh, I'm sorry, yes. Okay, so like I mentioned at the beginning, we don't check in the clip project definition because everybody might have a different version of clip and that. So what you can do is in SPT, so I just came out of it with Control C, reloaded it. There is a target called, it's a plugin called the clip. By running this, create the clip project and class path, not project and not class path, okay? So all you have to do is run a clip. There's one for IntelliJ, if you like IntelliJ, right? They're just plugins. If you want, you can do a with source. This, it tries to download also the source jar for all the libraries depend, which is incredibly useful if you're trying to debug, because you can just look at the code, right, the library depend on. So I highly recommend it, but it's obviously going to download a lot more than it already does. But anyway, so you run Eclipse with source through, and it goes through again, resolves, it starts downloading things. We did a clean, so it's going to have to download. As you can see, sometimes it doesn't find them. It tells you, oh, I couldn't find that, I couldn't find that other one. But they're just warning because they're source files. The one thing to keep in mind, and this, we can talk about this maybe, well, so if you change dependencies, so let's say you're upgrading the library, you have to go through and not only do the update that we talked about before, to update the jar, but also run Eclipse again, because it needs to update the project and the .class path so that Eclipse knows that there's a library. You do this, now you have that .project and .class path, So you can either, so at this point you can import it inside Eclipse, same way you always import an existing project or existing project workspace. Or if you already have it imported, you can come here and you can say, you have to say refresh. Because otherwise, it's going to think there are errors, it's not going to know about the jars. So that's kind of, the flow every time you upgrade or you update one of the jars, you make changes in terms of the dependency. You have okay. Yeah, so you can actually do, yeah, you can do tab completion. So if you do W and then hit tab, so yeah, and then you can, yeah. Now, since we're here, I'm going to mention something real quick. One of the nice things about Scala is that, like Python, um, under interactive languages, you have a const start. You can do that in SPC, and then load all the jars actually have on the tab. So if you hit if you type console inside Medici, play inside the project, it will open a Scala console, and it will actually load all the libraries, all the code. So this is really cool because when you're debugging, instead of having to debug by creating new files, you can actually do from the console in here. So you can do things like import models. I did a tab complete. What models do I have? These are models inside my project, right? I can file empty. Now I've imported that. Now I can actually call methods on file empty and tab completion, right? You can't do this easily in Java, which is one of many reasons why this makes this a little more productive than willing. But, yeah, all right. So at this point, hopefully, you have imported and discussed the code. Flipped, if you have the Scala IDE, you will have this Scala perspective up here that you want to select. Also, if you have an older Scala IDE, the one was 301 with this one. And one of the cool things that it does, Woody showed me, is that it actually has editors for the templates. So that the templates are actually color-coded. You can kind of read them better. Before, there was no editor for the Scala template. I'll tell you. But anyway, my point here is make sure you have the latest version of the IDE because there's some really cool stuff. I had to actually install okay, so let's go through the code, and the idea here is to a sense of how a play app is structured, and typically what we're doing in Medici. Um, if you get lost screen in something, um, I'm going to try to keep it high level, but some of the stuff might be depending on comparable or Scala, Java. Anybody need a second? So I should probably start the code review real quick. Yeah. And still have problems. Ask the person to your right. I'll say that. So so in the meantime, for those of you who have this running, before I get into the code review, okay, hold on. It's hard to juggle. Okay, and I'm making a step-by-step kind of tutorial that's manual for it. So you'll get the link to that one, and you'll be able to follow step by step. Yeah, I was hoping to have it done today, but not done. So that hopefully will be very, yeah, will be helpful. And please, send feedback about any of that. Once it's up. Okay. Okay. So real quick, if you're running the application, so going back to SPC, run in the app, and by default, if you go to data set, some pages compiling, like, really have to turn off the plugin. I'll show you how to do that. In fact, everybody else should not have this problem. I have the plugin all the time, but it's not. So some pages, like the listing of data sets, collection files, are open to the world. Like this search text box, you might see it or might not see it, depending if the plugin is open or not. I'll show you how that works. But the important thing is, go to login. You can sign up here, down at the bottom. Put in an email. Now, you have to have an SMTP server specified inside the configuration file. I'll show you that in a second to actually get the email. By default, is point to localhost, but nobody has an SMTP server. So what happens is you just got to walk the log the URL you need to enter. So create an account, and then check the email. Oh, there's an error somewhere over here. So please follow. You get an email with it. If you have an SMTP server defined, I'll show you how to define it in a second. But if you don't, on your local machine, you can just pick the URL, come in here, and then sign up. Okay? So once you sign up, you can come here, log in, remember the password. So now I'm logged in myself, and you can go to things like create a data. Okay, going back to the source code. All right. Okay, so that's fine. In there should be this. Please follow this link. This is basically the HTML5 that gets sent to you in an email. So let's start with configuration. So how do you configure it? Okay. So if you go to the main app, Medici Play, and you go down to comp, there is a folder called comp. All the configuration files are in here. So if you go to the comp directory, under comp, the main configuration file is application.conf. The syntax of this configuration file is pretty standard, but we're not going to talk much about it. But there's a bunch of things that you can enable or disable. Also, these configuration files are specific. They're not Java property files, so you can do things like include other configuration files. So here, we're actually including another configuration file called Secure Social Conf. Secure Social is the plugin that we use for authentication and OAuth. So down below under conf, you see there's a securesocial.conf. This is another configuration file. In here, there is an SMTP, and you can see that it says host localhost. So depending on where you are, can actually put in mail server to actually send email out. You can specify a bunch of others, of which really the most important one. Most SMTP servers are left open on the network, but if they're not, you can specify username and password. Also in secure social, there is a support bunch of OAuth providers, and the tokens for those are set here. Twitter, Facebook, Google, LinkedIn, GitHub, Foursquare, and user as password is that we're looking for. Basically, if you set these up, you're able to log into Medici using one of them, credentials from one of them. You also have the ability, if you want to interact with the service, that is called service endpoint on one of them. Let's go back to application.com. There's a bunch of default ones. I'm not going to talk about every single one of them. This is an interesting one. Because there is no state server side, like I mentioned, if you want to kind of keep state across requests, you either do it in some sort of distributed cache yourself, or you can put it in a cookie, and all cookies are encrypted. And this is the key that encrypts the cookie. So you want to make sure that you have your own key. It's long and scary, and that you have this deployed on multiple machines. The same key needs to be on every single instance, so that when you come with a request from your browser, it actually can read. Down below, there's a couple of other ones that are kind of interesting. You can ignore evolution. Loggers, you're going to change the loggers. File path, this is if you're using a service that stores file local on the disk. By default, you use Mongo to store the file. But if you want, you can put things in a directory. This is the Mongo DB URL. By default, it's localhost, the name of the database test. But if you want to be secure, you can put all these other kind of information here above. These are RabbitMQ, which we haven't really talked about. Parameters, the default are fine the way they are for development. Versus for multimedia retrieval. This is where you can specify new MIME types. So it has a built-in list, but if you have other ones that it doesn't know about, there's some of them that we use, mostly 3D stuff. Connect. You can here. Swagger is what we're starting to use for documentation to document the API. It's actually not documented yet. I won't talk about it too much, but you're going to be able to use it pretty kind of end user documentation of the API. Okay, that's the configuration file. That's the main app kind of configuration file. The thing that I really want to show you is plugins. So this is how you turn on and off different features inside the system. You can't really comment it out. You actually have to delete lines. But for example, if you're using Elasticsearch as a way to detect search, you want to load this service. This is the order in which they get loaded. It's arbitrary numbers. Big numbers for services are not important, and low numbers are important. All this is a class under the service package. So if you go to app, services, you can see that's the name of the class, Elasticsearch plugin. Plugins are a built-in feature of Play. They have a life cycle so that you can think when they get started and on stop. On stop, close the connection. So for the most part, for features that talk to external services that you want to be able to turn on and off, you want to use the plugin. So I have all of these turned on. I'm not going to go down to it, but there's the RabbitMQ plugin. So that's why, Liana, you were getting an error, because it was trying to connect RabbitMQ. Just delete this line, restart, and you won't get that error, and you won't connect RabbitMQ. I'll show you in the code how we can do things like, if this plugin loaded, then do something, right? Which is the useful thing about plugins, that, right, that you can have real plugins where you can load them on and off and show different things in the UI. So for example, this text box up here only shows if the Elasticsearch plugin is okay. All right. So what happens when a request comes in, right? This is listening on a port, and it talks HTTP. The first thing it does is it gets routed. So under configuration, you have routes. This is where you map a route, so a URL, to a particular method inside a class. It's kind of hard to read on the screen, but this says controllers, users. Controllers is the default package in which controller. So what basically handles that request and sends back a response. These are HTTP requests response, right? That's all they are. So as you can see, up here at the front, you can specify the actual verb, get, post, and so on. The nice thing about this is that in the code, you're always going to be referring to kind of the class method. So if you wanted to serve files at a different URL, instead of having to go in and change the code, all you would have to do is come here and just change it. And everything should work if you don't use static URL type code. Which we'll apply in a second. I'm going to keep it pretty high level because we're not going to be modifying this code very much today. Maybe in our next tutorial we can talk about some of how you can modify some of the code. But in a nutshell, you can have these column ID. These are dynamic, so it catches whatever you pass in the URL. So files plus some string of characters, and that gets passed into the method file. The method file on the class file inside controller. So if you go to controllers and you go to files and you look up here, there is a file method which takes in the string, right? Yeah. Okay. This is the scary part, which probably looks scary only because you're not using Scala, and also some of this code is written when you aren't really Scala very much. Some of it is better, but I guess my point is the quality of the code right now changes between classes. We're trying to clean it up as we learn, but don't be too scared. Some of it might be scary only. But really, here's the definition of the function. File takes in an ID and then spits out a secure action. So everything that takes in a request and returns a response inside a controller is an action. There are default actions that come with display, but we have wrapped some of these in special actions that we call secure, things like permission. So only users that have show file can actually go to it. Otherwise, you can't do that. What you see is, so here, let me show you real quick. So let's do a little list data set. I'm going to pick the data set. All right. So this data set called versus has two files. One is a PDF drawn here on the page, the JavaScript library called PDF. Java. And then there's an image at the bottom. So if you take this data set, this is coming in as a get on data set plus magical ID. We go and look at routes. Down here, there's a get data set, column ID, data set ID, controllers, data set, and over here we have data set ID. Okay? Only somebody who has true data set. Okay. What's happening in here? The main thing is previewers find preview. So we're calling for get all the previewers. And then we're also calling service data set ID. So what is this? Services is how in the master, how we dependency stuff. This is where we map certain services, specific implementation. So what we're saying here is that the service that allows us to get data in this particular instance is going to be implemented by MongoDB data service. And this is done using something called take pattern, which I'm not going to spend time discussing. But the bottom line is that there is a level of indirection where you'll see interfaces like dataset service, the bunch of methods and not implementation, and then you'll see things like MongoDB dataset service, or MongoDB dataset, which actually has implementations of these methods. Okay? So what you have to take away from this is that in the controllers, really what you're trying to do is take a request, create a response, but if you're communicating with any of the services, including the database on the back, you want to go through service. So you want to keep the code to actually access information to that database. I'll talk to RabbitMQ, I'll talk to Elasticsearch, right? But that's separate from the actual action, right? And you want to ideally do it through services so that it's easy to replace. In this case, for example, MongoDB with a Cassandra implementation. This level of indirection is kind of confusing. This take pattern is built into the language. What we have is, and what we're probably going to migrate to make this feature is implementation with Google Java library. I want to show you real quick what that looks like. And I apologize. But this way you can actually and how they interact with each other. So if you go to make play and you look at, there's a bunch of branches. One of them is called I could easily switch to it on the desktop, but because I'm not going to spend time on it, I'll show it over here, web interface. And what that looks like, familiar with Juice, there is a PI where you find dataset service, MongoDB dataset service that looks kind of similar. But the nice thing about Juice is that the injection, you don't have to have a couple of classes that actually establish the relationship, like I was showing, I showed you a bunch of classes. This is all you have to do. Wire them, and then there's a service stays the same. There's some changes in whether they're classes or objects or like that. The MongoDB dataset changes a little bit, but really not much because of the same implementation. What really changes, the big difference, you need to be aware because once you switch, it's going to be different, is that you look at the controller's data set, now we actually have singleton inject data set with the file service. This is something that you're familiar with. You see the same thing done in Scala. Again, this is the link between Scala and Java, right? The idea that you can be with the Java library. But the cool thing about it is that once you inject them here in the constructor, then anywhere down below, it actually makes it even easier to call that particular service. data set service here. When we list, here's the data set. All we say is data set get, which does that service call. So this is basically, dependent injection, right? It's very simple. All you do in the constructor, you say, I want to be able to access data. And then the system behind the scenes decides, right, at runtime, whether it's going to go get them in MongoDB, in memory, right? It makes it really easy once you set it up to have different implementations. And then you can drive which implementation you're running against at runtime. So if you're writing a unit test, right? Last week we talked about unit tests. You can use implementations in memory. So you don't even have to have MongoDB run, right? You can mock service, okay? So this will become more familiar as you work with it, but just be aware that in the master right now, you do this dependent injection one way. Soon enough, you'll start seeing the juice, and all really not that difficult. All you have to keep in mind is that the wiring is done inside. Sorry if that was too technical. Yeah. The result is the same, although just make something like at runtime test set up prior. But it just basically makes it so you have to write less classes, because the cake pattern requires you to write a lot more classes, and it's also it's comparable for people who know Scala and some of the inner workings of Scala. Very complicated. So you have to do wild things like there's a level of interaction here where you have file service with Mongo and file system. Look at then you have but there's these extra layer of direct that makes it more complicated. So that's it. Yeah, but it's minor. The only thing is that the big change in the code, all controllers start having service. All the controllers have all the controllers. Yeah, yeah, this goes away. Yeah, but still have a different file. File. But they also, like the other thing that it does have modules that create modules. That's something that we have more like modules. Then all you have to do. So this is something that actually you don't have. This injector over here right now is doing the following. Saying it's asking play, are you in production? So if you remember, you can start the application different ways. You start, then you're in production. So in that case, it creates the injector in the production. If instead you're doing running, it creates this step. And then we're going to drive some of this from the configuration file. Even in there, you can see things like, I want to use MongoDB, I want to use Cassandra, I want to use, right? So some of these nice things are not built in the previous one. A little more okay. So what I'm going to do is I'm going to finish the flow of request response, and then maybe we can take questions. If you look at controllers, we said, okay, data set. We do a bunch of things in here, a bunch of things in here. eventually, and this is fairly complicated, this is old code, there's a lot going on in here, this can be cleaned up. But at the end, there's okay, which is basically saying, okay, return a 200, everything went well, and then pass in some text, some HTML. But the way we do the HTML here is we use templates. So we say, I want to use a template. I want to use the used HTML dataset template. And I'm going to pass in a bunch of variables. Okay? So if we go down to use, these are all the templates. Now, this dataset template, like this. This is one of the more complicated. But all right. Okay, so this is a template. Okay, so a template is just like any other templating system. You have a bunch of HTML interspersed with things like at, if, so code in it. These are the parameters that were passed in inside the action, right? You have a bunch of data. Which one is the previous one? What is the next? Then this is how we wrap an outside template. So this is header with the menu at the top. That's the name of the template, main. If you jump to main, this is how we wrap main. So main actually has the menu at the top here. And then in here, we okay. And then in here, we have some static HTML and some if statements, the usual template stuff. And then that gets, this gets created and returned, and then you get HTML on the front. Before we take questions, I want to just quickly mention that look at controllers. These are the things that create HTML pages. We look at views, which have HTML in them, templates. They'll also have JavaScript in them for places where we use JavaScript. We haven't really talked about how to use JavaScript. I'm sure maybe later. And then we have models. So models are kind of the class, the main object that gets passed around. So this is what a data set in memory is. And in our case, the MongoDB object gets mapped to this data set object that has some of them, like metadata, are very generic, while some of them, like created, are very okay. So, and really, in a nutshell, I mean, this is really all there is here. API is a set of controllers like you have over here, but instead of returning HTML, all of these return and accept JSON. So this is the API, the JSON API. So if you go the app, you do a get on an API endpoint, so this is data set, and API, there's only certain methods. Here's the JSON for all the data sets, right? And there's a bunch of methods in the API. In fact, there might be more endpoints as well. But there's a bunch of methods in the API, and we'll see how we use them in the extractors, because the extractors, when they run, they actually talk to the API, write and read from the repository, right? Okay, so question. Again, I'm sorry if this is a lot, but there's no other way than showing what's there. Silent. Okay. Silent. Yes. How was it generated? You have to make it. So in the routes file, so let's say you want to add a web page, right? That shows you all the users or information about. Well, I have that. But basically, you would just manually add it. So you just add line, something that you manage. Everything in play actually gets compiled to Scala for performance reasons, including the routes file. So if you have problems while you're running and you get runtime exceptions, you can actually go under target and look at the code. Okay. Class. What? Okay. Anyway, somewhere here, there's the actual class that we're creating from. You'll never really have to look at them unless something horrible goes wrong, but you can. So everything, all the files, also the are actually compiled in what are called added Scala XML because they're actually compiled in Scala. Oh, all right. Don't mind that. But yes, so what you would do is you would add here a route, then you would create a controller or add to a controller, and then you would implement the controller. That's it. And I was going to show that we could do that today, but unfortunately we're running out of time. So, and what we really want to do is give you a sense of how preview are constructed. In the controller, the last thing you do is you call the method, whether it could be typical error or OK or a request that went well. That method you pass in. You can pass either plain HTML, you can pass the view, and I'll show you. For example, this is the one to create a new collection. You say, okay, everything went well. And then you say, view HTML, new collection. That's the name of the template. But because these templates have Scala classes, that's clearly just package in which they're in, and that's the method. Yeah. Yeah. So um, I can show you on screen. All right, I created a template. I'm I'm gonna make sure that I have the rest of the app around me. So here's some JavaScript. As you can see, you can just put JavaScript inside the template, right? So a lot of JavaScript inside the app, which is JavaScript inside the template, and include them. And I'll show you, for example, the previewers are in a special place. Actually, I should show you that. This is just plain HTML. So you go to the route. Okay. Yeah. Ooh. Then instead of creating a new one, scissors. Not pass anything in. Have the basic action. There is no nothing plain. And here, okay. This is the annoying part. Is you could do code completion on this one, but it doesn't see through because you haven't actually refreshed the app. So it doesn't compile the template. Otherwise, so we say foo, and now over here, you go to here, filing stuff. Again, this is a little slower than usual. Some of the fun. Yeah, I did the shortcut. You can create a new one if you want. You can create. Those are controllers, right? That actually done. And okay, so I reloaded everything. I oops, I gotta turn on it. So I'm gonna go to play plugin. So this came back, and we just got right. Right now, you can dynamically pass in all sort of functions, right? All sort of model information dynamic in the data. So, for example, and then there is the JavaScript. So, for instance, go to data set, um, this data set, and put in a tag. This actual communication, and I'll log in. This actual communication is done through the JavaScript. That calls the API. So first, render the page, render there's tag, tag. And this actually does an AJAX call using some JavaScript to the API endpoint, and then updates the tag. And that's an example where inside the data set template, right, there's a bunch of JavaScript. And really, this file right now is really big, so this is all JavaScript. But there is simple ways to compose the different templates together. Anyways, so for instance, this one at the top, these are actual snippets that get called down below, and these could be their own separate templates. So, templates don't have to have everything in it, and you can reuse one template as part of another template. That's something that we are learning. Okay, last piece, does that help kind of show you the relationship? Last piece, if you look under public, that's where, so if you go to the main directory and public, you have all the static resources, images, JavaScript. So for example, we bunch of libraries, like, we use jQuery, right? So you put it in here. If you have more specific ones, like Dragon Zoom In, you can put it in here. These are just static resources. And in the template, you decide whether to include it or not, right? This is where previewers live, and I'll talk about it a little bit. Style sheet, there are style sheets. There's a main style sheet and some specific style sheets that we have here. Again, these are specific previewers. Main is for the entire app. But most of our styles are built on top of Bootstrap, which is really popular. That's why all apps look the same. It's Medici. We are going to rectify that soon. But not familiar with it, which was a bunch of CSS development. We're upgrading to 3. But the reason why I bring that up is because the CSS that you are familiar with Bootstrap, when you download, you get a bunch of CSS and JavaScript. They're actually built with something called Less, which is a macro language to create the CSS, which makes it easier to create variables and all that. Play has a parser, a Less parser built in. So we actually, up here, inside the app, there is a folder called Asset Style Bootstrap. These are the actual Less files. So instead of having to build upon the CSS styles in Bootstrap, you can dynamically modify the original Less. So this looks like CSS, but there are things here that are not. So that's how we can modify if we want. If you want to modify the look and feel right now, this is one way. The other way is to just override the style inside. Okay. All right. So more questions. I think this is helpful at all, or is this boring as hell? Okay. No question. All right. So what happens when something gets uploaded? I'm over a new data set. Oh, no. Uh, 56 is MP4 file, top corner. It's a very small video. The name, description. By default, right now, when you create a data, you specify one file. There is no reason why it should be one or many. You can do once you create it, you can have a file. Anyway, so we go ahead and we upload. It tries to show it to the page with a particular preview. So, like we said at the beginning, preview is an extraction or a point where you can extend, right? So they're both based primarily on MIME type. So the raw bytes go up there, but then the system tries to guess what to use to preview it. Okay? So if it can show it, right, if there's a previewer that can do in this particular case MP4, right, that's the MIME type, then it tries to show that. In the meantime, in the background, there are a bunch of, this is on my local machine, I have started a bunch of extractions. Yeah, we're running out of time, so um, let me show this demo real quick. Okay, so let me make sure I have all of them running. And we'll talk about what take right one. Okay, so what happened here is this was not running. So this is an extractor that takes the MP4 and tries to do some basic computer vision on it and create sections or identify shots inside the video. It wasn't running, but although it wasn't running, the app, when it uploaded it, it sent a message to RabbitMQ. And it said, hey, look, there's a new video here. Maybe you have one extractor running somewhere on some machine that knows how to deal with it. Okay? But it didn't find anything, so it kept it in the queue. And then when we started it, it actually said, oh, do you have anything that is an MP4 or a video? Oh, yeah, okay, so I'm going to go ahead and work on it. This kind of thing is, was not as trivial to set up the previous version. Also notice that I'm running all the different extractors separately. And third, you can actually start many instances of it, and they will, RabbitMQ, through RabbitMQ, they will each one get one at a time. So you get the fan out automatically, right? Okay. So, okay, so let's go quickly back to here. If I refresh, we can see that there's a new previewer. The previewer shows you all the sections inside the file. We call them sections generic, but really they're just shots. And these are the shots. There's only 4 of them. And down below, there's another little previewer that shows you a list of all the shots with information about when to start. We haven't talked about sections very much. We tried to do it in version 1, and we really want to highlight this in version 2. It's this idea that extractors can identify sections inside a file. So for example, in the case of a video, it's shots. In the case of PDF, it could be pages, right? It could be anything based on what the extractor knows. But the bottom line is that the file can have sections. Sections are indexed inside a file in specific ways. One of them is time information, right? But in an image, we use this to do the pixel, right, location. So you can create, you can leave an annotation something inside an image by, pick a spot of it. So that's the section, right? And yeah, and you can play this file first that JavaScript is actually communicating with that page, and as you play the file, advance side. Again, it's just a simple kind of preview. If you want, you can upload more files that go into the data set. Now, if you scroll down, you got that thumbnail that's on. So again, that tag is a section of it. Right? So data sets of files, files of sections. Yeah? Okay. All right. Okay, so now back to the technical stuff. Sorry. All right. Let's install RabbitMQ. So for those of you who want to follow along. The easiest way to install RabbitMQ, well, so that's OS dependent. Because we're running out of time, I'm not, I don't expect everyone to get working. But if you look at in the README, some information here about how to install things. You have to update this. The reason why I bring this up is because once you install RabbitMQ, you want to run this command to install this plugin called RabbitMQ management. You don't have to, but this is your web interface on the broker. So you can go now to local host. This is all port that it runs on. So when you start RabbitMQ, I start by following. Just again, there's the command under SBIN in RabbitMQ, and that's really ready to start. It starts, and it tells you a bunch of information, including some of the modules installed. In this particular case, web management things that allow us to have pretty kind of a visual representation of what's happening in the broker. This is very helpful for debugging and on. Also, for queues, you can see that there's a bunch of each one of these queues is actually one of these extractors that we started up. Okay, so for example, the one that did identify shots inside video is this end system cinematic. You'll see that some of these have a bunch of ready jobs, and some of these have a bunch of total jobs that have been finished. So they're ready to start, but they haven't started. This is because these are jobs in the queue for which I don't have an extractor running locally. Okay, so you can actually come here and see what the stats. For example, you come here and kill the one that does trigonometry. Yeah. So if we come here and kill this one, there is still a live queue that does nothing. Now, if we go web app, we say create, click a file, upload. If we go to the here it is. Well, here we see Cinemetric as a job in the queue. So now you can go back to the web app, and you can see this is the known bug, but basically you can see that the file is here. You can come and if you want, download a small file. That's a bug. But the thing is, come here and start the extractor, then it's going to ask the queue, and it's going to start working on it, right? So go back to console, the Cinemetric doesn't have one ready because it's actually unhacked. And I'll tell you a little bit about actual action, and this is working on it eventually, right? So you can monitor it. So you can monitor all the. There's a bunch of information about channel exchanges, connections, more advanced stuff. Really, the thing that helps most helpful you will here. When you look at them, you'll see a bunch of. You specify this name for the queue when you build the extractor. These are automatically generated. They're actually callbacks for these extractors. Because one of the things we are doing is using RabbitMQ to have logs of stats for the extractors come back to the app, so that we can keep track of stats of the different extractors. Okay, so the relationship between the front end and RabbitMQ is somewhat clear. Or any questions? You need to wake up. All right. So, unless there are any questions, at this point, I was going to lead everyone to actually creating an extractor in a preview because we don't have much time. I'm going to show you what it looks like an extractor and a receiver. And maybe next time we can actually do an activity. I'm going to try to make that part of the manual so that people can learn that offline without talking to someone. So let's start with extractors. If you go to Dash, one of the you have the code in the Medici project, you'll see down here, I just added a extractors Python. This is supposed to be check there. Okay. So you can write extractors, actually, okay. You can write extractors in different languages. That's because the only thing that extractors do are listen, talk over RabbitMQ, which has a bunch of libraries that you can use to communicate, right? Every possible language out there. And then you do RESTful call against the API. So that's all HTTP and JSON. So the only requirements of an extractor is that it can do RabbitMQ or really AMPQ, and then that it can HTTP and JSON. That's all you really need. Okay, you can do it in any language that you want. It doesn't have to be a language. So far, we have done Java, Python, and Scala extractors. And there's a list here, different ones. The core, when you're getting started, has a bunch of them. We got to split this apart. This has too many extractors. Each one of them should be somewhat standalone. But in here, two easy ones are the ones under NCSA image and video, because they're fairly basic to set up, and it's really only one Python file. That's all it really is. The one that I'm going to check in under extractor Python is kind of similar. It actually has no dependency. It has two Python dependencies. And it's this file over here, and it tries to be as simple as possible. So I'm going to kind of walk you through this. This is Python code. We encourage people to use Python only because very simple to set one up. Really, all it is a Python file. While in Java, you have to set up a Java file with dependencies. You have to compile it. We have examples of that, but we're trying to make these as lightweight as possible. So that's a file that is a file that is an extractor. This is a Python extractor, an example of an extractor written in Python. Now, if you want to look at it, it's not checked in now, but if you go to extractors core and you go under NCSA image, maybe I can show you this. And extractors core NCSA image. Yes. So let me talk about this one first. Everybody can take a look at it if you want. Okay. Okay. So. Well, this is an example. Let me show you this other one just as classic code. And I'll check it in. You can take a look at it. But I'll talk about this one, but it's very similar to that one. Some of the code is copied. There's a main method, Python main method. This is a key that is required by the API for things that write to the system. Yeah, I don't know. Oh, better? Yeah. Okay. Okay, he let me in. So every time you're writing to the API, I showed you here the API call. If you're actually adding information, you have to provide a key, like it did. By default, we have this let me in. It's hard-coded. What we're doing is making it so that users can actually create by the system. So every user can have their own key. By default, for development, just use let me in. This is the name of the receiver. This is what you see inside the RabbitMQ console on the left, right? So you can call it whatever you want. This particular receiver, this particular extractor is something really simple. You just take the CSV file and make tab limit file. So instead of commas, tab. Trivial on purpose because it's an example. Now, a lot of this stuff is basically setting up the RabbitMQ connection. Most of the time, you're not even going to worry about what you do. Once you're more advanced, you can figure out, you can talk about what exchanges are, the type. These are things that are specific to RabbitMQ. This is how we're using RabbitMQ. There's all sorts of ways of using RabbitMQ. For now, I would say just keep it the way it is. Once you get more familiar with it, you can use it. The most important thing here to keep in mind is that the queue name, right, receiver, so that we are standing on that queue, we're listening on it, right? So if we want multiple receivers to do different things listed on the same, we can use it. In the case of we can use it. In the case of this type of exchange topic, which again we don't have time to discuss, but RabbitMQ has different types of exchanges, which means how the messages are routed from the publisher to the subscriber. In this case, you can actually specify a routing. And in this case, we're saying we want anything that has in the routing key anything, followed by anything, followed by text, followed by this is the MIME type we're talking about. This right now is out of a list of 3 data set, file, and preview, because we handle previews in a special way. So when you upload something, you need another representation of the original byte. We call that a preview. So in extractors, most of the time, we'll take the raw bytes and we'll create a preview. That preview is just other bytes, right, in a different format that highlights something inside, right? So I'll show you an example when we preview. So this is one way to listen. Now, and then we start listening, we start consuming over here. This consuming, basically, over here we specify the method of message. Again, okay, let me explain this. One thing is Pika, if you want to look it up, and again, I'll put it in the notation, is what we use RabbitMQ driver, right? That's what it is. So all that we're doing here connecting RabbitMQ is Pika. And the other library that is required is called request, which is the Python library to request HTTP request. Okay, parse. Okay, so what do? Every time a message comes in, we parse, using request, the body of the message. The way we send information over the message, right? The way when something gets uploaded, right? We send this message. That message, information in it, is stored as JSON. RabbitMQ doesn't enforce a particular format of the message. We just decided JSON and expect it. So we're just parsing whatever is in there, and I can show you the code. But we're parsing things like the host. This is the ID of whatever we're going to work on. So we fetch the data. This is just a request, the API for files, file ID, and we pass that key, right? You could do this from the browser, you could do this from curl. All we're doing is getting the blob, right, the byte to work on them. In this particular case, it'll be a CSV file. Then we go through the file, and we run the extract method on the file, and this simple Python code, given a CSV file, creates a new file that's tab delimited. Then tab delimited file is uploaded as a preview. Again, these are just API calls on the web app. We post the preview file, and we store a bunch of metadata about it. In this case, we just say, oh, well, this preview file, the MIME type is the MIME type tab separate value, which you have on string. And then, we post the metadata again, and we're done. We return from extract, and then we acknowledge. This is the most important thing, in my opinion, on extractors, that you always acknowledge at the end. If something goes wrong, it doesn't get acknowledged. You can always roll back, and next time a extractor comes online, they actually will pick up that message. Right? So when you're debugging or when you're running in production, if something goes wrong in one of them, the message goes back to the queue, and so you actually don't lose it, right? Okay. So because we're running out of time, I'm going to show you a previewer. Okay. Any questions while I do something real quick? That actually is not an extractor. That's just a previewer. Maybe I should show you that one. I'll show you that one. Yeah. So previewers, they either take the derived preview blob of bytes, or they can actually just stream the original blob. The preview extractor does that. It streams the original blob. So let me show you that.
Yeah, I'm wondering if you were extracting the text to make it searchable.
Yeah, so that could be an extractor. One thing that Rob also was bringing up is that because of the way that we're doing extraction now, you actually have an easier way to split up different operations that you do on the file. So for example, before we had a PDF extractor that extracted metadata as well, created a new version of the PDF that would be able to show on the front end. You brought up that now you can just treat them as two separate extractors. One might extract text to index it. The other one might create a new version of it. So extractors are under public JavaScript right now. This is actually because previewers. So this is where all the extractors right now are. You can actually just add a folder. These folders, these extractors are loaded at runtime. So the app looks for what's available. And the way it does that is it parses everything that is under previewers. Each of these folders is an extractor. So for example, PDF.js. And it looks for these package.json files. And this is plain JSON. And we require right now only three things: a pretty name, some main JavaScript to run. In this case, some library. This can be called whatever you want. Some library is actually a really bad one. The first couple of ones were some libraries, so everybody kept some libraries. But you can give it whatever name you want in here. And then content update support. So this one supports application/PDF. So this runs some library. And this is just JavaScript. And unfortunately, we don't have a lot of time. So I'm sorry that we'll do some hands-on some other time, or I'll put them in the manual. But what you do is, for every extractor, you always want to start this way by passing in an instance of jQuery, because we like jQuery and we're using jQuery now to make our life easier. And then this configuration object. The configuration object has information about the file and the previews that you're going to use in here to actually show that or retrieve information about it. So for example, tab is the actual ID of the element in the page where this is going to be appended to. So in this JavaScript, we actually create the preview and append it to it dynamically, right? So for example, in this particular case, we append a button, previous page, next page, rubber band canvas, and a rubber band ID, right? So we are dynamically appending elements to the page, and those elements are appended below the tab. Where did I put the PDF? Oh, this is this one. So these are the two buttons. And then down below, we append something else. Because you can have multiple tabs, they need to be uniquely identified. We actually append to these tabs unique IDs for each previewer. So you have to use that configuration object. The configuration object has also things like, this is a complex example, I should have done something else. Actually, hold on. There's a simpler version here. Okay. So configuration.url as the URL of the file. So we build the file URL based on the configuration object. So this is API/file/.unique-id. So in here, we create an element script, and we load the JavaScript library that allows us to draw on the page the JavaScript. So we're dynamically loading the JavaScript. So if you go to pages that don't have PDF files, you're not going to be loading the library to draw the PDF. And then this is just specific to how the PDF viewer works. You have a PDF object, which is defined in this JavaScript library. We pass in a file URL, and we embed it on this element, and we pass in some ID. But the bottom line is that we're just running the JavaScript here on that element. So that's what draws this. So this particular one, it's a JavaScript library. It's a previewer that runs in a, it's included as a separate JavaScript object, and then you can go through it. This is actually communicating with the server side and grabbing the bytes of the PDF, the raw PDF. So this is an example where we actually don't use the preview. Okay. It's noon. As always, it took longer than expected. I apologize if this was too much in one go. I try to keep it high level, but I had an extractor and a previewer. The extractor you saw, I had a previewer that showed timelines for every column of the CSV on the page that I can use as I can put into documentation. The other thing is we were talking about maybe doing more of these for individual projects as need be. But I hope that this gave you kind of an overview of where the code is and what you need to run it, so that as we move forward, right, we don't have to do this again, and then we can talk about the specifics. So we'll have more documentation about all the details somewhere. And the other thing to keep in mind, if you play around with the code, is make sure that, keep in mind that we have a bunch of branches, and all of these have all sort of code in them. We're trying to keep the master clean, and I'm gonna try to always send out on the mailing list. If you're not on it, Medici developers.ncsa, you should get on it if you're developing, because if there are drastic changes to the master, I'll try to notify everyone. Yeah, there is a bunch of stuff on here that we didn't discuss. So for example, a lot of sensor stuff is in the sensor branch. But some of these, you can just switch to the branch and try it out if you're interested in seeing some of that work.
Well, I'll just add to it. I don't think anybody expects that you understand everything that we just saw today here. It was just a lot of information. But for me, from my perspective of like Roundup, for example, this gives me the idea of where to go within the Medici code base, I brought a lot of questions to my mind in terms of what needs to be done and where I can actually find the places in Medici where these things need to be done at. So it's just a start of a conversation in my head. This is not by any means the end of this.
And hopefully it empowers everyone also to give feedback, because we're developing this as we speak. So anything that you see that you think you can improve, right, that we can improve, I mean, please bring it up. This is so that you know how things work, so that we can all improve it together.
Yeah, so again, what came out of this for me is a bunch of questions.
Good.
Where to go for those questions.
Okay. Thank you, everyone.